Assalamu alaikum. Let's start lecture number 36. We will discussing this lecture. We will solve problems that will be related to static. That will be statically indeterminate problem, and one will be the deformation under transverse load. And we will use the equation of elastic curve. The method of superposition is using the appendix T. We already discussed one problem in previous lecture, but this lecture we will only using the equation of elastic curve to solve the problem. Okay, let's start. Topics. Okay, first we have for a cantilever beam. The cantilever beam is shown. Determine the equation of elastic curve for portion AB. So we have to develop equation of elastic curve for this portion AB. And the deflection at B, so we have to find what is the deflection at B and slope at B. Okay, so we have a distributed load W. Total length of the beam is 3A. From A to B, the distributed load is W. The length is 2A, and the B to C there is no distributed load. Only we have a concentrated load at free end C, and this distance is A. So in order to develop, first we have to draw free body diagram and we have to find the reaction at A. So free body diagram we can make like, so we have a distributed load till 2A. We have a point load acting over here. So let me put P, and let's take the reaction, and the reaction moment will be at A because it's a cantilever beam. So taking positive, sorry, in this direction, and we have, let's put RA. Now, RA, so we can write sum of forces in y direction is equal to 0, taking y direction is the vertical direction, and upward direction plus WA, that will be a concentrated force, minus 2 by 3 times WA, and it must be equal to 0. So this will lead us to that RA will be equal to 4 by 3 minus 4 by 3 WA, means the force 4 by 3 WA will be acting downward. So our assumed direction will be reverse and it will be acting downward. Now for the moment, so let's take moment at A is equal to 0. In this direction, take positive. So this will lead us to, this must be equal to 0. So this will lead us to MA, negative MA, plus moment due to this distributed load we convert into concentrated load, and it will be acting at A. So this will become, the force will become 2 WA and the distance will be A. And we have minus due to P. So force is 2 by 3 WA and the distance is 3A. And this must be equal to 0. And when we solve it, so MA is equal to 0. So only there is a reaction force, no moment acting at that point. So now we know the reaction. So we have to develop uh, equation of elastic curve for portion AB. So for equation of elastic curve, let me take a section between AB, and let's take this section as D. Okay. Now this section D, if I draw a free body diagram for this section, it will be, we have a distributed load W, right? And the shear force reaction at A, we already calculated, that is 3 by 4 WA. So following the sign convention, so if shear force V acting downward, we will take positive, and the moment acting in this direction, we will take positive. Okay, and this is valid for we take a section at D, and let's see. Okay, so moment. If I want to write moment equation for that, and this distance obviously will be x. Now, if we take moment equation, so m plus 3 by 4 WA x minus Wx, that is force, and it will be applied at x by 2, so this must be equal to 0. So the moment equation will be simply Wx squared by 2 minus 3Wax by 4. Now, the differential equation of the elastic curve, we can write Wx squared by 2 minus 3 times Wax by 4. So this is the equation, differential equation of elastic curve, and we will use to find the equation of elastic curve for portion AB, and also we have to find deflection at B and slope at B. So let's see. Now the differential equation of elastic curve was we have EI d2y by dx square, and we have equation of moment was Wx square by 2 minus 3 Wax by 4. Sorry, 4 by 3, sorry, that was 4 by 3, not 3 by 4, that was 4 by 3. Okay, now if we integrate it, so by integrating it, so we have E dy by d theta x, or we can also write as theta. Now if we integrate it, so this will become Wx cubed by 6 minus 4 Wax squared by 2 multiplied by 3. And we can also write this as plus C1 as well. So this 2 will cancel this one. So this equation will be Wx cube by 6 minus 2WAX square by 3 plus C1. Okay. Now, if you again integrate it, so we have EI y, and that will become WX4 by 24 minus 2WAX cube by 9 and plus C1x plus C2. Now what boundary condition we have? So cantilever beam, so at A means x is equal to 0, theta will also is 0, and at x is equal to 0, the deflection will also equal to 0. Now, putting first condition that x is equal to 0, so theta will equal to 0. So this equation, the above slope equation, will become C1, the value of C1 will be 0. Because if you want to write, so this become EI 0 W 0 cube by 6 minus 2 WA 0 to a WA square by 3 plus C1. This leads us to C1 is equal to 0. And equation of elastic curve will become, the equation for the slope will become EI theta WX cube by 6 minus 2 WAX squared by 3. That's it, because C1 is 0. Now second condition is when x is equal to 0, y is also equal to 0. So EI 0 W 04 by 24 minus 2 WA 0 cube by 9. C1 is also 0, C2. So this leads us to C2 is equal to 0. Now, equation of elastic curve EIY will become WX4 by 24 minus 2WAX cube by 9. So these are the equation of elastic curve, and this is the equation of elastic curve, and the above is the equation for the slope. No, sorry, not this one, this one. This one is giving us the slope. Okay. Now we can find what is the slope and what will be the other value for deflection at V and slope at B. So we can easily find using these equations. So part A was to find equation of elastic curve for portion AB. So this is for portion AB. Okay. Now, the equation, so let's see deflection at B. So we are solving part B. What is deflection at B? Well, let YB we have to find. Equation of elastic curve was EI Y we developed. So that was equal to WX4 divided by 24 minus 2WAX divided by 9. So at x is equal to 2a, that is at b, so we can write EI YB, so that will become W 2A 4 24 minus 2WA, sorry, this is cube, 2A cube divided by 9. So when we solve it, YB, we can write 1 over EI, and sorry, by solving it, this will 10 WA4 divided by 9 EI. So this will give me the deflection at B. And part C, we have to find what is the slope at B. So the equation for the slope we already calculated. So that equation was EI theta WX cube by 6 minus 2 by 2WAX square by 3. Now theta B, so we put we have to find theta B, so x is equal to 2a, so in this equation, so we put that will become EI theta B is equal to W 2a cube divided by 6 minus 2WA 2a square divided by 3. And when we'll solve it, so simplify it, so theta B will be equal to negative 4 times WA's cube divided by 3 times EI. Negative sign means the slope, the angle, this theta B is in clockwise direction. Okay, let's see another problem related to this topic, and that is statically indeterminate problem. So if you look at the statement, determine the reaction at the roller support. So we have to find what is the reaction at B, and when we have to draw bending moment diagram for this loading shown. So for the bending moment diagram, we must know what are the reactions for this beam. So first, let's draw a free body diagram. Let me draw a free body diagram over here. So we have a moment at A, that is unknown. We have reaction at A, that is unknown. The only known is P, and we have reaction at B as well, that is also unknown. Okay, so if you write sum of forces is equal to 0, y direction is equal to 0, so that will equal to RA plus RB is equal, sorry, minus P is equal to 0. And or we can write RA is equal to P minus RB. So that's it. We cannot have calculate. So if we take moment about A is equal to 0, moment at point A is equal to 0, so that should be equal to 0. So this will lead us to MA, minus ma plus PL by 2 force multiplied by distance and minus RBL is equal to 0, or if I want to write MA in terms of RB, so RBL minus PL by 2, that's it. So we have equation, this equation, and this equation from static equilibrium condition, 3 unknowns but 2 equations. So that's why we have to find the equation of elastic curve. Okay. Now, for equation of elastic curve, so let's start. Let's take a section between A and C, somewhere here, and let's draw free body diagram for that section. And let me change the color. So we are making free body diagram. Okay, and we have a force over here that is RA. We have a moment at A. Let me write MA. Shear force acting downward will take positive, and moment, this is positive, and let this distance will become x. Okay, now this equation is this cross section is available is this distance or from A to C, right? That is between A and C. So the moment equation I'm going to write M minus MA minus RAX is equal to 0, or M is equal to, if I want to write, that will become MA plus Rx. Now, equation of elastic curve, if I want to write differential equation of elastic curve, so that is EI d2y by dx square MA plus RAX. If I integrate it, so EI dy by dx is equal to max plus rax squared by 2 plus c1. And if I further integrate, so ei y max squared by 2 plus rax cubed by 6 plus c1x plus c2. Okay, these are the equation for slope and deflection for the section between A and C. Okay, now but this is only valid from 0 to L by 2. We have to consider what is happening beyond CBC, somewhere here. So we will develop equation of elastic curve for this section as well. Okay, now let's take a section here, and if I draw a free body diagram for this one, and now this is from L by 2 to L, the whole length of the beam. So we have MA RA, we have a P, and we know this distance is L by 2, and we have shear force acting downward will be positive and this bending moment M. And we have to develop this equation of M. Okay. Now, if I want to write moment equation, so that will be M minus MA minus RAX plus P, and that P will be equal to X minus L by 2, and this will be equal to 0. So moment equation will be equal to MA RAX minus P X minus L by 2, right? Now differential equation of elastic curve for, and now this is formed between, this is for portion C and B, between C and B, EID to y by dx square. So this equation will be, sorry, there will be a positive sign over here, MA plus RAX minus P times X minus L by 2. So if I integrate it, so this will become d1 dy by dx, or let me write in terms of theta as well. So this will become MAX plus RAX squared by 2, and this will become minus P by 2 X minus L by 2 square plus C1. Okay. Now, not C1, C1 already taken, so let me write C3. So if I integrate again, so this become EI y, so that become MA x squared by 2 plus, okay, what else, R A x cubed by 6 minus P by 6 and X minus L by 2 cube plus C3X plus C4. Now these are the two equations that is valid for uh, our section CEP. Okay. Now what boundary condition we have? Okay, let me write the previous equation, that previous equation of the elastic curve. So that was, we have, let me change the color, pointer color. So the previous equation, the two equation that we derived for section AC, for AC was EI theta or EI dy by dx, and that was MAX plus RAX square by 2 plus C1, and EIY, that was MAX square by 2 plus 1 over 6 RAX cube plus C1X plus C2. Okay. Now, if you look at this, this is for valid for AC. This equation is valid for AC, these two equations. Now at A, we have a boundary condition. Means if I want to write the boundary condition, so at x is equal to 0, that is at A, so the theta will 0, and deflection is also 0. Now if I put in this equation, because this is equation boundary condition, sorry, let me write, this is confusing from compared to previous one, so let me write, these are the boundary conditions, and that is applicable for the curve AC. Now if we put these values, so C1 is 0 and C2 will also 0. Now these two equations will reduce in form, so this C1 will become 0 and this C2 will also become 0. Okay, so we have EI theta. So these equation will become EI theta or EI dy by dx max plus RAX squared by 2, and the other equation EIY will be equal to MAX squared by 2 minus, sorry, plus RAX cubed by 6. Okay, but the other portion in the constant are still unknown, so we have to find the way to find where what are the constant. Okay, just remember these two. Okay, let me write these four equation again, and let me write the equation for that we already simplified for the portion AC. So that was EI theta or dy by dx. So we simplified it. So this equation was mx plus RAX square by 2, and other equation was EY MAX squared by 2 plus RAX cubed by 6. Now let's consider portion. So let me consider for portion CB. So what the equations that we derived was sorry, not d2y, dy theta, and that will be equal to max plus RAX square by 2 minus p by 2 x minus L by 2 square plus C1, and the other equation was EI y MAX square by 2 plus RAX cubed by 6 minus P by 6 x minus L by 2 cube plus C1x plus C2. Sorry, this was C3, C4, not C4. Okay, now what boundary condition we have? So we have boundary condition that at x is equal to L by 2, x is equal to L by 2, deflection at C for curve AC will be equal to deflection at C for the equation CB, right? Means if I put x is equal to L by 2 in this equation, and the deflection if get, so that must be equal to deflection if I put in this equation, L by 2, right? So, and what else boundary condition I have? Second boundary condition is that at x is equal to L, the deflection is also equal to 0, means it's a pin support, so overhead the deflection will also 0. So this equation, if I put in this equation x is equal to L, okay, so if I put x is equal to L, so this must be equal to 0. And what else we have? Now at x is equal to L by 2, we have another equation, that is theta will also equal. So theta c due to of the curve AC will also equal to theta c of curve CB. So this equation means if put x is equal to L by 2, so this theta and this one will equal to 0, right? So by putting this, we get the value of C3. So let's put this value first. So we are choosing that at x is equal to L by 2, theta C of curve AC is equal to theta C of curve BC. So when we put the value, so L by 2, so this will lead us to MA L by 2 plus RA L square by 8 is equal to, now for this above equation for curve CB, so again it will be MA L by 2 plus RA L square by 8, now minus P by 2 L by 2 minus L by 2 plus C3. Now if this term will become 0 because PL by 2 minus PL by 0. So this, if you look, MAL by 2, MAL by 2, this will cancel out. RAL square by 8, RAL square by 8, this cancel out. So this leads us to that C3 is equal to 0. So now this equation is further simplified. Okay. Okay. Now, if I put x is equal to L by, if I put x is equal to L by 2, and considering that YCC AC will be equal to YC BC, obviously both should be equal. So if I put this equation, since C3 is 0, so we can take this as 0. So let me change the color so that C3 value is 0. And if you put it, so that will become MA L square by 8 okay plus RA L cube by 48, right? This is for this equation for the AC, and this should be equal to again MAL square by 8 by putting in this equation the above equation for CB, and plus RAL cube by 48 minus P by 6, and that will become L by 2 minus L by 2 cube plus C4. Now, this term MAL square by 8 will cancel MAL square by 8. Right hand side, left hand side, RAL cube by 8, 48. RAL cube by 48. These two will also cancel, and we have P by 6, L by 2 minus L by 2. This will lead us to C4 is also equal to 0. Now, what we have? C3 and C4 is also 0. Now, the equation of elastic curve will further reduce, and this C4 will also become 0. Now, what we will do, now we know this expression that is in terms of MA and RA, right? And if you remember that we already calculated MA and RA in terms of RB. And if you put the boundary condition that at x is equal to L for segment CB, so y is equal to 0. So let's see. Okay. So the equation of elastic curve for section BC, what we have. So that was EI Y. So since C3 and C4 0, so we have 1 MA x square by 2 plus RA x cube by 6 minus P by 6 x minus L by 2 square. Okay, now if you remember from the static equilibrium condition from the free body diagram, we found that RA was equal to P minus RB, and MA we calculated in terms of RB was equal to RBL minus PL by 2. Okay, now let's put first this at x is equal to L. This will lead us to YB is equal to 0. So this equation will be EI 0 MA L square by 2 plus RA x, x instead of x, that will become L cube by 6 minus P by 6, that will become L minus L by 2 whole cube, not square, sorry, this is cube. Now, this, if we replace MA with RA L plus L by 2, so if I want to write RB L minus PL by 2, that is MA L square by 2 plus RA will replace with P minus RB L cube by 6 P by, minus sign, P by 6, that become L by 2 cube, and this will equal to 0. So when we solve it, so RP will be equal to 5 by 16 times P. Okay, and if you put in this equation P minus, so RA will be equal to 17 by 16 times P, and the moment equation, the moment will be at A will be by putting the value of RB, that is 5 by 16 PL minus P by L by 2. So that will become, moment about A will become roughly around minus uh, 3 by, it will come 3 by 16 times PL. Okay, now you have all the reaction and forces acting on this beam. You can draw shear force bending moment diagram. So you have to draw bending moment diagram, and the bending moment diagram will be, so you have to try this at home, and you will try how to draw bending moment diagram. So this will be starting from minus 3 by 16 PL. So, and at C, it will be, so at midspan C, it will be 5 by 32 times PL, and it will be 0 at P. So bending moment diagram will be like this, and you have to try at home uh, with this how to draw bending moment diagram for this. If you have any question according for that, we will discuss.